The Veris machine, this is one of the newer ones. It has 3 sensors. Lewis will go through it a little bit more. It's a Coulter-based electroconnectivity sensor. This version also has an organic matter sensor and an on-the-fly pH sensor. So it literally takes a soil sample on the fly and then reads the pH. The tank is water, and it's just her watching the pH probe. So we ended up also pulling behind an EM38, which is another type of electroconnectivity sensor, and we're running them simultaneously off the same GPS system. So we've got an RTX system. It's close to RTK. It's a little bit technical to get everything working together. We ended up buying a ruggedized laptop rather than all the crappy monitors it came with, quite frankly. So we've actually got dual monitors in there. One runs the EM38, so there's 3 sensors on the fly that are taking measurements, and then the side monitors where we put our EM38 data collection so that we know we're taking data properly and effectively. Sometimes you'll notice the numbers will be off, and then we have to stop and recalibrate the instrument. So we trick. Well, that we can do whatever we want. What we do is we set the monitor to whatever width of swath we want to take. So we tell it we're pulling a 60-foot cedar kind of thing. It'll put me on 60-foot swath. So usually we try to match it to the width of the cedar, because if you're going to do it for variable rate applications, you can't manage any more than the width of the cedar as far as resolution is concerned. Lewis came out here on Friday and mapped this chem fallow section, and he did that on a 40-foot swath. So typically they're done in that 40 to 60-foot range. Yeah.
We generally run at 55 feet is what our...
There you go. So you're in the range. I'm not lying to you. So the calf sled didn't come with the M38. We had to buy that at UFA. Not yet, no. Yeah, no, that's a completely separate unit. That's the EM38 unit. It's another type of electroconductivity sensor. The EM38's been around for like 50 years. We happen to have a newer one that's a dual dipole, so it actually will take measurements at different depths. And then if we turn it on its side, it takes even shallower depths. So what you're doing is basically mapping different sections of your soil.
So again, how far down will this one go? I mean, on the pH and the other ones, so that's all just your top.
The pH and the organic matter are obviously just like the top 6 inches. The pH is, you can set the depth of that core to wherever you want. If you want to be at, 2 to 3, 4 inches deep, or if you want to be 4 to 5 or 6 inches deep. It takes a core about that big. So that's all needs to be set based on the soil conditions. But when you take a soil test to a lab, you're usually interested in organic matter in your top 6 inches, right? The organic matter sensor on this one is an optical sensor. You can see that thing just lifted up. That's actually the pH sampler. That front coulter there, what it does is moves the trash out of the way and almost kind of blackens the soil up, because we want to be able to get through that residue to take a proper soil core on the pH sensor. And we also want to be able to see the soil clearly with that optical sensor, which is used for the organic matters. So it's all GPS enabled. If we use the guidance to have nice straight lines, I think the 40 or 50 or 60 foot swath allows you to map nice and even across the field. And as we're doing it, then you're also collecting a topography map that's pretty darn accurate. So that's the nice thing, right? With this setup here, you're getting an accurate digital elevation model. which can be used for variable rate purposes or for drainage purposes, whatever you may be. You're getting the electroconductivity, the pH and the organic matter at whatever depth that you want. What's that? It drops down every so often, takes the core, the soil actually flows through there. You can take a closer look and you'll see the soil will shoot through there. Whenever it pulls up, that's the soil sample it takes. There's 2 pH sensors that go into that soil, takes a reading, and then it drops back down, and then the water washes the sensors off. So that's the real purpose of the water, but there's actually a dual purpose. It adds a lot of weight to the machine that helps keep the coulters down, because we want to get the coulters into the soil to get that conductance reading. Yeah. So there's a number of consultants that use these. The reason that we have them is we wanted to be able to put some independent testing towards the instruments. We're not really trying to compare the EM38 to the Varus, but we do have that ability. And honestly, so far what we've been finding is that the measurements are very similar, and that's expected. They do measure conductivity in different ways. One is inductance and one is conductance. You got her working?
Gotcha.
Okay. So our project that we ended up putting together with this instrument was on the conductivity side. Who knows, have you guys heard of electroconductivity before? What do you usually hear about it for? What's it for?
Salt content.
Salt content,
Moisture.
salinity, moisture. Is that what we're using this machine for, you think?
Well, you never know where it's going to show up, but you can get hidden salinity too that shows up in areas, right? That you
Yeah.
don't know it's
So what is salinity?
comes down to salt content too in your soils, and it changes plants can't. You end up drying out in water basically because they can't metabolize the salt.
This that osmotic pressure where it kills the plant. So, yeah, the conductance, the measurements that they do, it's literally measuring the electric current through the soil, and that is related to a few things. The salt content. First of all, you have to have moisture. If you just had plain distilled water and you tried to run a current through it, what would you get? Nothing. Remember your chemistry class, attaboy. I'll give you a hat for that one. So as soon as you put, what's it called when a salt is dissolved? Anybody? Come on, Chem 10. Hey? So salt breaks up into its ion forms. They become anions, which are negatively charged, and cations, which are positively charged. It's actually those ions that conduct the electrical current. So if you think about this in relation to salts, lots of salinity like you mentioned, we're going to have a high reading with both of these instruments. So they are actually very good at picking up types of salinity. However, that's not truly the application that these machines have been used for. Does anybody know what they're actually used for in mainstream agriculture? You got to know.
Soil type.
Soil type. Elaborate.
Soil classification. So what the EC machine will do is the speed through different types of soil. So it's faster through a clay soil because your molecules are tighter together than it does go through a sand soil, which you have basically, when you drop sand out of your hand, you can see the molecules fall. And that's how it reads a little slower through that. So
Slower or lower?
lower.
Okay. Pretty close. Yeah. Remember I mentioned the water? It's really the water and the anions and cations that are conducting that electrical current. So if you've got a sandy soil, do you think you have more surface area in a sandy soil in between the pores or less than a clay? You have a lot less. Yeah. I know the molecules are bigger and it looks like there's bigger spaces, but with a clay, the clays are very, very small and you end up having tons of little clay particles, and the overall surface area in a clay soil is way, way, way higher than a sandy soil. And that's the assumption that's being made here, in that in a sandy soil, the readings are going to be lower simply because there's less water in between the pore spaces. If there's less water, there's less anions and cations to conduct electricity. On the clay side, it's the opposite. So a clay soil will have a higher reading because there's more water. Same thing in irrigation management, really, when it comes down to it, is that bucket that they talk about when they teach you irrigation management in a clay soil is bigger than a bucket in a sand soil, and it's very much similar. Cation exchange capacity plays a role, and what we're trying to test then, and everybody will say that there's a good correlation between conductivity and soil texture. So that's the opportunity I think that people are using with these instruments, is that ability to sort of map the texture of your soil. Remember I told you how we're able to take different depth measurements? So we can take that measurement and sort of decide, okay, so we've got that type of a reading, we'll correlate it back to our actual soil samples, and then you can take the deeper readings. You'll start to get basically a 3D picture of your landform, and it may give you the opportunity to manage it differently. It gets a little bit complex, but I think there are ways that we can try to manage it simply and effectively. Unfortunately, the more you study, the more questions tend to arise, and it gets complicated. So it's really our job, and agronomist jobs and farmers' jobs, to try to sort out through the noise and figure out what it is that we can control and what we can apply with these technologies. Same thing with the drone technologies. Lots of technology that comes out. The trick is to use it properly and effectively. That's going to give you a return on investment and not give you a headache. So our project now that we're using these instruments for, originally we started off trying to collaborate with some local agronomists that have these instruments. It ended up being a little bit tricky because, first of all, they're trying to run a business, and then scheduling us in to do fields was difficult. But we also tried to do grid-based soil sampling the same day that we ran these instruments. So we actually managed this spring, we got about 15 to 1,800 acres done across the entire province. We were as far up as Falher and the Peace River area. So what we're doing then is mapping a quarter section. We're taking 5-acre grid samples, and then we're doing the nutrient analysis in the top 2 feet depth, but we're doing a full textural analysis in 1 foot increments down to 4 feet deep. And what that does is allows us to generate a data and correlate it back to the readings on the machine. So instead of just having a pretty map that gives you sort of differences, we can not just correlate it, but calibrate it and understand where the machine correlates properly and where it doesn't. You know, because if you have a salinity overrides everything. And once you have a salinity area, you cannot pick out that texture difference. And that's a little tricky here in southern Alberta. As you move into other areas where there's no salinity, then usually the readings are based on that difference in texture. So what Lewis ended up doing in your handouts is map this field just for fun. And it gives you a real good picture. Do you want to tell them which to refer to?
Yeah, so I ran both sensors over this field a couple days ago. And so the maps are in the handout there. So there's one with that. Well, first of all, you can see the EM38's map as well as the Verus maps. The first map here is the Verus, and then on the back of the page is the EM38. And you can see that they're strikingly similar. They both use different methods to assess the EC rating of the soil, but they in our experience with most of the fields we've gone over, the results are incredibly correlated. So what I did after I took a look at that map is I came out this morning and I took a couple soil samples. So I have 2 stakes. There's a big one straight here, and that's where I had the highest zone of EC. And then I've got a stake kind of close to the edge, right against the canola there. I don't know if you can all see it. It might be behind the truck. And that was my zone of lowest EC. So if you want to maybe come take a look at the samples I took, and you can they've kind of dried out a little bit, but I think if you feel it, kind of break them up a little. Like this one is definitely more more sandy, and this one's more clay, which is kind of neat that you could see it even in such a small area. And you can come in and kind of...
Yeah, texture is one of these things that feeling is really important. So the map, first thing that I thought was, wow, there is an incredible amount of variability in a 5-acre piece. Like imagine over a 1/4 acre piece. So to reiterate what he said, this one here was the highest EC reading. So right here, you guys can actually, this is the low?
Yeah.
Which one was the low here?
So this one here is the high.
That was the high?
And that's this core. And then the one at the edge there, that was the low, and that's this core here.
Yeah. And you can visually see the difference. So that tells us that the reading actually is doing something proper, and it allows us to differentiate, differences in soil types. So once you get into that that level of understanding of your fields, it is another layer of management. There is a cost associated with that, but we're hoping that at some point you'll be able to use that knowledge and recoup some of the expense to that. The one thing that's neat about these instruments is that you probably don't need to map it every year. You probably don't even need to map it in maybe ever again, to be honest with you. Your soil, as long as you're managing your soil properly, the likelihood of topsoil depth and soil texture and structure isn't really going to change over time. So that's one benefit that I see of the type of instrument. So there is no silver bullet approach when you're looking at this sort of variable rate types of applications. The one thing that I've been saying lately is that you can't take a cookie cutter approach to managing variability. You have to take a variable approach to managing variability. So that's really important. So you start off with a base understanding of what you have, and then you kind of layer the different types of tools and technologies that suit your needs appropriately. So I kind of got into mentioning it that we're doing 5-acre grids on 1/4 sections. And that gives us a great opportunity to correlate the actual readings back to a physical lab test. So we do the gravimetric tests and get the percent sand, silt, and clay. And so far what we've been finding is that we're not seeing a tremendous correlation on a field by field situation. But when we lump up all the fields together, that's when we start to see a linear relationship between the texture and the EC readings. Like I mentioned earlier, we have to be careful. If salinity readings come in, then we have to deal with that completely separately. Once we finish this project, we're actually quite interested in sort of zoning in a little bit more specifically into the salinity side of things. What's happened in the last number of years that might affect salinity in your guys' fields?
Continuous cropping.
Sorry?
Continuous cropping.
Continuous cropping, yeah.
Water.
Yeah. The big thing for me in the salinity side of things is, we can do everything right, continuous cropping, if you want to grow alfalfa in your recharge areas and all that sort of thing, you can manage everything for 15 years and think you've got salinity under control. And then in 2010 you have the flood of the century, and 2012 you have the flood of the millennium, and it seems like every 2 years we have some flood. Those type of flood environments, they can wash away all your years of management and bring that salt back up. So we're thinking that there's more salinity issues now since the flooding than maybe in the last 10-20 years. So it's becoming more of a problem. How many of you guys have salinity issues? Yeah. So there's a difference between sort of a visible salinity and then the invisible salinity. If we're talking EC lab type data, what value do you want to be suspicious of as far as salinity is concerned? 2? Yeah, they say kind of 2, anything of 2 to 3 maybe above there. That's when you're gonna be careful. If you're doing this EC mapping, you have to be cautious that the EC values that you're getting off here are not the same as your EC lab. This gives what's called an ECA, an apparent value. We can do some math and convert it to a lab test EC, but it's something that I just wanted to warn you guys if you have the desire to hire somebody to do some mapping. Yeah. So we're doing the grid soil sampling, we're doing the mapping. What we're doing after that is following up with a prescription research trial. And what we're doing is we're sort of employing plot research on a field scale. So it gives us the opportunity to look at the spatial variation. So we're doing replicated nitrogen response curve in a block design. And what that is allowing us to do is kind of a reverse engineering approach to precision agriculture. Rather than just create a map and say, there's differences, we can create zones. By doing that research trial across the entire field, we can see how is it responding in each one of those zones, whether it's an EC zone or whether it's one a farmer drew in from his own knowledge, or however other method or other type of information that you can do. So we're kind of excited about that. It's going to be a lot of GIS work on Lewis's part, but any type of information, any layer of information, so we've got the EC layer, the organic matter layer, the pH layer, we could have the topography layer. We're going to correlate that to see which is really influencing yield, so that we'll be able to sort of choose what's the most effective method if you're interested in doing the variable rate type application. So we're in our second year of that. We're going to finish up, we're going to do some more mapping this fall and next spring. And by the end of it, we're hoping to have a better understanding of the limitations and the opportunities with these types of instruments. It's always cool to have a new technology, but we'd like to have some solid information about how can we use it and what's the best type of thing. Another thing that I want to mention is that calibration in these and skilled people operating them is really important. Even in this spring, I noticed when you start watching the data points on the EM38, all of a sudden they're reading differently, and whatever the reason, temperature affects it, we have to recalibrate it, and then all of a sudden the numbers are back again. So it's great to generate data, but we don't want bad data, and we don't want it to be interpreted improperly. So there is a challenge there. There is work to be done on the data processing side of things, but overall they're pretty cool. My impression so far, if you're interested mostly in the conductivity side of things and kind of getting an idea of texture, this instrument has a lot less moving parts. You could probably even drive a little bit faster, maybe go on narrower swaths in the same amount of time as this machine. So there is that side of it. However, with this one, compared to this one, we lose the ability of that extra organic matter and pH sensing. But they do both perform, I think, quite similarly as far as putting a conductivity measurement down.
That one's more difficult to calibrate too.
There is
cost-wise.
this brand new dual dipole is about 18,000. That's about 35,000.
A bit of history. I was helping a fellow at Swift Current years back, many years back, and they had a winter array, which is two 10-foot farms that folded out.
Oh yeah.
Push pegs in the ground every 20 inches or so.
And then you're doing hand measurements?
Sent the current through those, depending on how deep they were and so on. You got your winter array reading, a similar reading, I'm sure.
Oh, okay, cool. Yeah, these the company's more of a geological company. You can actually have different instruments, EM other numbers that can go down, 50 to hundreds of feet down. So they're using it for geological exploration and such. So this is sort of the agricultural based version. We did have some headaches trying to make all of the technology work. It seems like the more technology we have, the harder it gets sometimes to make it work in a simple way. So we ended up, I mentioned we got a ruggedized laptop. We got 4 serial ports on there because the USBs are not working properly. So there's a lot of technological hurdles in trying to get, to make proper use of some of the neat technology that's available. But it can be done. and we hope that the more people get involved, the software, that's, you know, there's always software issues as well, but for the most part, I think there is a use for these instruments, and we're looking forward to learning a little bit more about them.
Yeah, they're not like, the technology is by no means new. I think there's been a lot of application for it. I mean, like this EM38, the technology's been around 50 years or something. But I think there's been the last maybe decade or so, there's been a bit more of a push to kind of bring it into agriculture. And I think a part of that is because we've got a little more, like, variable rate technology is a little more accessible. We're thinking a lot more about managing variability within our fields rather than across different fields. So I think, yeah, again, and Ken's kind of said it, like, it's all great to get the information, but I think the real question with some of these sensors is what's the value of them, and how can we find that value for them? And I don't know if Ken mentioned it before too, but we've kind of been looking at yield maps as well, and so we're going to kind of see how well they relate to that. Can conductivity kind of help to explain, you know, some of the high yield potentials or low yield potentials that we see over the past 5 or 10 years in some of our fields. Yeah.
One of the applications that we're going to be doing, and we had a module on farm research at our field school this year, is one of the tricks to on-farm research. Like UCC plots, we talked about all the different products that are available out there. So unfortunately, I don't think we're going to be in the business of testing all these products for farmers. And I think farmers are going to have to take that boat into their own realm. So what I like about, say, this machine, you can map your field and have a better understanding of the variability out there, and maybe pick the areas that are the least variable and set up some plots. And the research that we've been doing with this project is so simple. To create a prescription map that we use for research is not a lot of work with a lot of the software that's out there. You plug it into the rate controller, and it's just like doing a variable rate map. It'll automatically change your treatments. You can throw in some replication and randomization, and there's free software out there that'll run statistical analysis. I think we probably do need to put on some more workshops in that arena, but the last thing that I want farmers to do is go out there, test these products, and then not have any confidence in the results that they're showing. So that to me is sort of the next wave. To me, on-farm research comes first, and then more variable rate type management. So
you got some mobile canola plot samplers coming.
Canola
Plot samplers coming there.
what am I looking at?
Right there, walking through right
Deer?
through the field there.
We have moose here?
No, we didn't.
Right on.
Get the gun.
Right on. Speaking of that, I just got my deer tags in 102, so if any farmers want to let me on their land to take care of those pesky buggers. It's just kind of south here, yeah. Yep. Oh, thank you. Too bad.
116, I got 210 coming.
Okay. Too late on that one, but I think that's about all we were going to cover in this module. Since it's so hot, I think maybe we'll go for an early lunch and perhaps see a demo if these guys are brave enough. Is there any questions from anybody on this?
And if you do have questions about the equipment or anything, like we've definitely found, we posted a few videos online a month or two ago and got a bunch of questions from all over the place. So I think people are kind of interested in both the Varus and the EM38. So come chat to me or Ken if you got any questions over lunch or whatever.
What about the cost then to have you come do a test then? How does that work?
Well, if you want to collaborate on a research project with us, there'll be no cost.
Oh, I see.
So certainly give us a shout. All of our information is available on the website. We do, since we purchased these machines, we do want to continue further studies. I'm not exactly sure what we're going to do, but you know, one thing, even in that 5-acre map, like this is what it does is allow for smarter soil sampling. You know, in the past, everybody says, oh, and then that's exactly what Lewis did. He picked one of the high points there, and this is what we're looking at here, and then the low points, and you can clearly see there's a difference. So, you know, to be able to do a little more intelligent and directed soil sampling is always a good thing. Yeah.
With that in mind, I've forgotten his last name, but Jim at Blackie, Alberta,
Yeah,
At,
the guy that's been doing precision ag forever.
Yeah.
Yep.
He was doing detailed grid physical soil sampling with a truck, of course.
Mhm.
And he would have lots of fields that he would have data on.
Oh, yeah.
Over the years back.
You know what I find is a lot of people do nutrient analysis, but they don't do the textural analysis.
Okay.
And that's where I think our project is quite unique in that, you know, we're doing that 1 foot increment textural analysis, sand, silt, and clay, because that's really what these readings are telling you. I may not have mentioned it, but organic matter will affect readings as well. Humus has huge cation exchange capacity, so there's lots of salts in humus, so we have to be cautious with that one. On another note, we can do 5 acre grid sampling, including 4 foot depth textual analysis in about the same amount of time that we can map it. And my soil sampler is home built, a couple $1,000, and when you come into a lab with a whole schwack load of samples, you have a lot of negotiating power. What really surprised me is how cost effective even grid soil-based sampling can do. Can be. It might even be cheaper than the mapping costs. So keep that in mind too. Like to do this, it's not that bad.
So you don't have pipelines.
You know, it's good that you mentioned that. We're learning and conducting on-farm research. We've been working on developing protocols. We face that this year a lot. Every time we do the one calls. Another study that I didn't mention is a new one. It's a canola-based study. And what we're doing is using multiple years of yield maps as a way to come up with prescription farming on the canola side of things. So we've divvied up all of the data into sort of low, medium, and high yielding zones. And then we find areas of the field where those 3 zones are side by side, and we do little study blocks. Just so happens up here at Greg Bowers, one of our study blocks was right in the friggin' middle of this network of pipelines, which really kind of messed it up because we wanted to take soil samples before and after. So we ended up having to switch that all together. So if we could do our sort of one call mapping ahead of time, and that's a cool thing about GPS now. If you ever do a one call, just go out there and map your own lines, and then you've got basically a shape file or of where all your lines are in the future. Unfortunately, some of the guys don't have that because they've been there that long. They just sort of know where it is. But anyway. Cool. Any other questions? Okay, well, thanks for coming. And if a reminder, if any of you do want to check out that grazing study with the winter cereals, let me know. Otherwise, thanks for coming and enjoy supper or lunch. It's sponsored by UFA, so thank you, your local UFA rep.